In this presentation, I'm going to be talking to you about energy generation and storage. It's an important part of the Design and Technology 9-1 GCSE, and you're going to need to be able to explain the types of renewable or non-renewable energy are, what their definition is, maybe some of the pros and cons. So I'm just going to give you a starting point here, and then maybe you can do some further research into specific methods and elements later on. So you've got to be able to talk about how energy is generated and stored. You've got to explain the advantages and disadvantages, and you've got to make sure that you're clear about the difference between the two. These days we're talking about non-renewable energy sources as things that are going to run out. Now we're going to talk about that as being finite. So you're going to run out of them eventually, they stop being available to us. Renewable energy sources are the big push at the moment where we're trying to reduce climate change and reduce our reliance on or other resources. They aren't going to run out. So renewable energy sources are green energy and they're not going to run out. They can be, they'll be with us forever. Okay, so what we've got to do is work out the best way of harnessing those processes and that energy. Okay, so examples of that include solar, wind, hydro, electrical, biomass and tidal. Now all of those are to some extent or another available at the moment, but as we'll discuss in a minute, there is a reliance still on fossil fuels and non-renewable energy sources for some very good reasons. Now basically any energy generation, or most energy generation, is done by turning a turbine, turning some sort of motor. And what happens is that generates electricity. That's assuming that we're talking about generating electrical energy. And the various turbines are turned according to the powers that put into them. So that's where you could have steam, or you could have hydroelectric, or you could have nuclear that are turning those turbines. But that technology actually isn't very different between renewable and finite resources. Okay. Resources such as wind and sun don't need to be replaced because they're always available. And in some places they're available in greater quantities or more consistency than in others. Okay? So we're talking about being green, we're talking about being environmentally friendly, we're talking about being sustainable. Okay, so fossil fuels. You probably know about these from geography lessons, you probably know about these just from reading it in the newspapers. We've got coal, crude oil and natural gas. And increasingly we also talk about fracking, where you kind of get a slurry which is oil stroke gas based as well. Fossil fuels are formed from the remains of dead organisms. If you think about the millions of years that have gone prior to our industrial revolution, that's plant matter, that's animal matter, that's little animals in the sea that have sunk to the bottom, and over millions and millions of years that material has become decomposed, it's become compressed, and it's been covered by more standard sort of soils and sands and silt. And so what we now do is we dig up that material as though there's an endless supply of coal or an endless supply of oil, and actually what we're doing is we're removing our reservoir of that material a bit at a time. Okay. When we burn those fossil fuels, they also release carbon dioxide, which at the moment is captured within that material. But that gets released out into the atmosphere, which contributes to global warming and greenhouse gases. It prevents the heat from escaping from the earth. Big issue is that eventually fossil fuels are going to run out. And when you look at the nations of the world that have large deposits or large resources of it, they're often quite wealthy if they're able to exploit those resources. However, as those resources run out, then we have a problem with where we get our power supply. But equally, you might argue that destabilises governments, that destabilises country. And that's another potential issue with our reliance on fossil fuels, particularly oil. Currently, there's quite a good supply. So we're talking about them running out in hundreds of years, some of them thousands of years, and they're quite easy to get to. Okay, they're relatively easy to find. Some of them aren't particularly deep, and that technology for getting to them is really well established, and great companies are very expert in doing that. Okay, it's a well established process. Just keep my presentation. Nuclear power. Now, when I was first investigating this, I was sort of surprised to find that nuclear power is basically a finite resource, because the uranium that it relies on to generate the heat and to generate the power that then that creates the steam that turns the turbines is actually based on a material which there's only a small amount of, and it's difficult to get hold of. So it is actually a finite resource. Interestingly though, the amount of power you can get from nuclear energy, and for the amount of time that it can produce energy, it's actually, in some people's opinion, a very green form of energy. So it's very environmentally friendly. The emissions are not the same as burning oil and coal in terms of carbon dioxide. But, and it's a big but, the waste material which is used to generate that power is very, very difficult to get rid of, and it remains radioactive and potentially lethal, and can cause birth defects and can cause terrible sort of problems within the animal kingdom. It has to be disposed of really, really carefully, and you have to make sure that we're talking about thousands of years worth of protection to other people who might come across that. So, you know, it's a very unpopular method of energy generation in some respects. And equally, if you think about recently, a couple of years ago, we had the earthquake which caused the Fukushima reactor in Japan to release nuclear water, cooling water, into the ocean and contaminate a large area. That was a major ecological disaster, which is a result of using nuclear power. Probably more famously than that, in relatively recent memory, there's currently a Netflix program about it, is the Chernobyl disaster, where the Russian or Ukrainian nuclear reactor melted down and caused a widespread devastation in that area, and for a long period of time, very difficult to contain. So serious problems for people, animals, wildlife living nearby, and it's a very, very long-term effect with nuclear power.
A nuclear power plant generates electricity using the heat released during the fission of uranium atoms. Several types of nuclear reactors exist. The world's most common reactor type is the pressurized water reactor. This power plant has three entirely standalone water systems: the primary system, the secondary system, and the cooling system. The fuel used by a nuclear power plant takes the form of small uranium pellets that are stacked in long metal tubes known as fuel rods. These tubes are placed in a steel tank filled with water, the reactor's core. The fission of the uranium atoms heats the tubes, which in turn heat the water to a temperature of 320 degrees. Pressurized to keep it in a liquid state, this water is then channeled to the steam generators. When secondary system water enters into contact with the primary system's pipes, which contain very hot water, it heats up in turn and becomes steam. This steam turns a turbine, which turns a generator. In the generator, the interaction between the electromagnets of the moving rotor and the copper coils of the stationary stator produces an electric current. A transformer then boosts the current's voltage to between 225,000 and 400,000 volts, thereby facilitating transmission over the grid's high voltage power lines. When leaving the turbine, the steam is turned back into water by the cooling system. It is then returned to the steam generator to begin a new cycle. Before it does so, it goes through a condenser. This condenser is either supplied with cold water from the sea or a river, or with water cooled by the draft that circulates in large towers known as water cooling towers. Generating electricity from a nuclear source produces radioactivity and radioactive waste. Facility safety is therefore of utmost importance. The waste is rigorously managed, sorted and treated before being safely stored. Nuclear power plants generate very large amounts of electricity and do not emit greenhouse gases. They are used continuously to meet the growing demand for electricity.
So this brings us on to probably our newer and hopefully slightly more interesting renewable energy sources. So for you guys, who are sort of looking ahead to your futures, renewable energy sources, there's all sorts of issues with them, there's all sorts of problems with them at the moment because they're relatively new. But as technology moves forward and as investment into these techniques improves, then what we're going to see is that they become more efficient, they become more widespread. That's not to say that there's no downsides to them, and that's not to say that they're entirely ecologically friendly. Okay, I've got a couple of questions on this slide that you can kind of use to form an argument, form a discussion as I'm going through these. There's great debates on both sides, financial, ecological, scientific, as to the effectiveness of renewable energy sources. Right, solar. Increasingly, you now see that on domestic roofs, industrial roofs in enterprise parks and business parks. You see it on fields, particularly in Cornwall at the moment, where I am at the moment. Large areas of fields are being given over to solar arrays, which is a number of solar panels put together, a bit like the image you can see on the right of the page there. And farmers are obviously generating rent from that, and the energy companies are able to create quite a lot of free electricity. Okay, now free electricity is a difficult idea because, of course, you've got to pay for the solar panels, you've got to pay for the installation, you've got to pay for the infrastructure to get the electricity from those fields to wherever it needs to be, where the substations, etc. So there is a cost to it. Great thing is we've got sunlight, billions of years. Okay, the sun probably will eventually disappear, but realistically, that means that we've got a free source of energy that, if we learn to harness it efficiently, will be with us for as long as we can imagine. The downside is, it also, whilst it's working, it doesn't produce any greenhouse gases. It doesn't produce any waste products in use. That's not to say in its disposal that it doesn't. Downside is, particularly in the UK, they don't produce electricity without sunlight, and the installation and maintenance costs can be high. So if you're employing people to build a solar array, you need to find a good spot for it. You've got plenty of sunshine, hopefully, and then the specialists need to come in and install that equipment. So there's a lot of cost to that. That's solar energy.
The sun is the most plentiful source of energy we have. It's about 4.6 billion years old, with another 5 billion years of hydrogen fuel to burn in its lifetime. That gives us a renewable energy source that won't run out anytime soon, and it can be used without releasing greenhouse gases or other harmful byproducts. We can use that energy directly for hot water, lighting, heating, and even cooling. We can convert it to electricity to power anything from camper vans to suburban homes to shops to industrial processes. Solar could be the largest source of electricity in the world by 2050. And with the largest levels of solar irradiance per square metre of any continent in the world, Australia's well placed to take advantage. We already are. Over 2 million households use solar technology, more than any other country. So how do we turn sunlight into something we can use? And how can we rely on it when it's only available during the day? The two main technologies are solar photovoltaic and solar thermal. Solar photovoltaic, or PV, is a way to convert sunlight into electricity. When light photons hit a photovoltaic panel, they excite electrons free, causing the charge to build up, which gives us electricity. These solar panels are often installed on rooftops, integrated into building or vehicle designs, or attached to power plants in very large numbers. We're working on low-cost panels that are environmentally friendly to produce, thin, and even flexible, so we can generate electricity from the sun in all kinds of places we couldn't before. The other technology, solar thermal, turns sunlight into heat. At low temperatures, we can heat water or air for residential and commercial buildings. But when we concentrate sunlight, we can get much higher temperatures, turning water into steam to spin turbines, which gives us electricity. We're leading the way on methods to get more out of sunlight by using mirrors and lenses. And we're finding ways to store it for use when the sun's not shining, a cheap and effective alternative to storing electricity in batteries. Our need for energy to power our modern economy is always increasing, but with the sun available and the right technology to harness it, we'll keep the lights switched on. Wind.
Again, really contentious issue, wind power. It's a proven technology, it's rolled out all over the place. That's both on land and out at sea. Wind farms rely on a large amount of wind as consistently as possible. So they're very often on the top of hills, and they're very often out in the sea, in fishing grounds and places like that where we get a lot of wind. But that means that they become part of our landscape, and for some people that's not something that they want to promote. Particularly if you live in a beautiful area of outstanding natural beauty. Maybe your house is quite a traditional farmhouse, or the area relies on tourism heavily. And if you suddenly plonk a bunch of wind farms down, you transform your landscape into something a bit more modern, a bit less traditional, and that can have a real impact on the people that live there and the tourism industries. So there's a bit of an issue there. Some people don't believe that they're particularly efficient. I think there's an argument for and against that. And also the materials and the energy required to produce these wind farms in the first place is actually quite damaging to the environment. For example, many of the turbine blades are glass reinforced plastic, GRP. That's not an environmentally friendly material at all, however they're durable, etc. Okay? Some people feel they're noisy, and some people think that they have an impact on wildlife. I'm not sure whether I know that that's been proven. I'm sure someone will be able to find some facts about that.
Wind power. Wind, although it might not need explaining, is moving air caused by differences in atmospheric pressure. Wind speeds vary based on geography, topography, and season. Because of this, like other renewables, there are some locations better suited for wind energy generation than others. In fact, there are optimal wind locations both onshore and offshore. Energy is derived from wind by converting the air's motion into mechanical energy. Traditionally, this energy was used for milling grain and pumping water, but today is most commonly used to create electricity. The mechanism used to convert air motion into electricity is referred to as a turbine. A turbine is a large structure with several spinning blades, usually 3. These blades are connected to an electromagnetic generator that generates electricity when the wind causes the blades to spin. Wind is becoming an increasingly important part of the global electricity supply mix. A major advantage of wind is that the production of electricity has no direct CO2 emissions. But wind generation is not without its challenges. As everyone knows, the wind does not blow all the time, causing intermittency issues for power grids. The price tag of wind power has traditionally been higher than conventional electricity generation sources, though the wind cost curve has declined significantly in recent years. NIMBY concerns such as land use, noise, and bird disruption have also been raised in certain areas. That's wind power.
Hydroelectric. Now, hydroelectric is really, really well established as a means of generating power. Typically, we do that using reservoirs and dams. And what will happen is that the water is captured in a reservoir, and then when it's released down the dam or through the runoff, it turns a turbine which generates power. Sometimes that water can be pumped back into a reservoir so that it's a form of energy storage, so that it can be released as and when it's needed. A bit like a bit like a rechargeable battery. Whenever you need a bit of power, you release a bit of water. Tidal energy, you see that nowadays being explored in tidal races such as the Severn Estuary, where people are looking at putting great big propellers, which again is the turbine idea, and every time the tide moves in and out, it causes a constant flow through those turbines. Now, that's not dependent on weather, that's not dependent on anything, because that's tides, which are absolutely predictable. So that means that they can be costed. Again, people will talk about that being damaging to the movement of fish and marine life. They'll talk about how that can cause silting up of particular areas. So there's people who will argue against it, but there's some interesting ideas around tidal energy. And you'll see a video where there's an energy generation platform which actually has moving arms which generate the electricity, floats on top of the water. So people are exploring all sorts of kind of slightly bonkers ideas and harnessing the power of water. biomass. Now, biomass is basically stuff that can be burnt to create heat to turn a turbine. And that the sources of biomass are anything that can be burnt, anything that's combustible. Now, obviously, what you're doing when you're burning stuff is you're releasing CO2 out into the atmosphere again. So, in terms of being totally environmentally friendly, there's an argument that this isn't so good, and also getting the waste material from wherever it's created and stored to the biomass plant doesn't have no carbon footprint. So there are issues around it. However, it's quite a good way of producing fuel. So a great example there, growing biomass crops produces oxygen and uses up carbon dioxide. So creating the fuel that can go into a biomass incinerator actually is part of that sort of virtuous cycle of oxygen and carbon dioxide through photosynthesis. It's quite an expensive way. It's not necessarily a well-established way of creating fuel at the moment, but it's an increasing technology. So biomass, it can be livestock residues, cow poo. You've got agricultural sort of waste where it's the bits that have been chopped off that can be burnt. You've got forest management systems which can all be fed into this sort of biomass process. So interesting. Have a look at the slide, read through that properly, and I'll show you a video about biomass.
Energy 101. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop.
And then we're into storing energy. I think I've spoken already about the storing of kinetic energy, where the water is pumped into a reservoir and then it's released as and when it's needed. So when there's low electricity demand, the electricity is used to pump the water up the hill. When there's a high electricity demand, it's available and it falls down using gravity. I think probably the thing that I would be looking for you to have a bit of an understanding of and to look at later on is batteries and battery technology. So we've got rechargeable batteries, and these days we're using cordless drills and materials with lithium-ion batteries that last for hours upon hours and charge very, very quickly. There's a moral and ecological cost to those, because the minerals and the materials that are used in their production and then their disposal later on are actually quite damaging for the environment, and some of the people that are involved in their production can be working in some very, very difficult and unpleasant conditions. So I don't think we can use rechargeable batteries such as our phones and our devices that we use all the time without thinking twice about it. Not necessarily, it may well be rechargeable, but it doesn't necessarily mean that it's entirely ecologically friendly. Now, as batteries get better and they can store more for longer, then obviously we rely on other sources of energy less, or we can harness solar energy and it will store for longer. So there's always a pro and a con, an advantage and a disadvantage, and that's going to be important, particularly when you're framing your longer answer questions.
to move around in. Here's how it works. With the circuit off, electrons in material A are stuck in their high energy, high stress atoms. Out of reach and on the other side of this electron barrier are material B atoms, which would offer an easy, cushy, low energy level position. Let's turn the circuit on. Now you've offered electrons a path to happiness. Since they can't go any other way, they begin flowing through the circuit to material B. Back at material A, the atoms are losing electrons, because that's where the electrons are coming from, and they begin turning into positively charged ions. As we mentioned before, ions always want to be neutral, so these guys need to find a negative charge. So they go to where the negative charges are, in material B, where all the electrons are going. You'd think that these ions would just meet up with their lost electrons and become neutral atoms again. But unfortunately, the electrons are way happier where they are now, so the ions have no choice but to kind of mingle with the atoms of material B. So what we've got is kind of a mishmash with B atoms mingled with A ions. As the battery discharges, electrons and ions are making their way from A to B. When you can't fit any more material A ions into material B, the battery is fully discharged. To recharge the battery, you just do things in reverse. Instead of a circuit, you're putting an energy that forces the electrons back into material A. The ions then leave material B and rejoin their lost electrons, and the battery is ready to discharge again.
Okay, so here's a bunch of questions. I think for me, how is energy generated using fossil fuels? What we're doing there is we're talking about that turbine and how, as it rotates, it creates the positive charge, which is your electricity. I think listing the main sources of renewable energy, maybe explaining why, isn't too difficult. If you follow back on this video, you've got quite a number of them available there. The advantages of using renewable energy sources are, well, it's about not wasting materials, okay, not wasting resources. And then if renewable energy sources are so useful and good for the environment, then why aren't they used more? That's a really good opportunity for a long discussion, a long argument, laying out the pros and cons of using environmental energy. Now remember, we're talking about some of it is unproven technology or new technology. Some of it requires quite a lot of non-environmentally friendly materials to get set up with. Some of it requires very, very specialist technicians and engineers to install it. Some of it requires quite a large impact on the visual and physical environment that it's put into. Okay, and then cost and reliability. So it's quite an easy 10 marks if you begin to kind of bullet point and list that. All right, so hopefully you found this reasonably useful as a starting point. There's a wealth of information out there, and I'll make sure that there's a couple of videos in here that you can have a look at. Thanks very much.